Assalamu alaikum dear students, welcome to CHM 42242 experiment 4P, that is complex ions of copper. To start that experiment, our step number 1 is we are taking the copper chloride dihydrate salt that is of sea green in color, as you can see in the picture. After observing the color of the salt, now you will add a small amount of copper chloride dihydrate to a dry test tube, and then 12 molar HCl very carefully will be added to the salt until it dissolves completely. You will swirl the content of the test tube gently and then note the color of the solution as it wets the sides of test tube. What is the color that appeared? You have to note down. You can see in the video. Once HCl, 12 molar HCl was added and shaking was done, so the sea green color of the salt changed to yellow colored solution. What happened here we will see in the next slide in the form of chemical reaction. We will report our observation. When copper chloride dihydrate reacts with concentrated HCl, or when it is dissolved in concentrated HCl, the chemical reaction that took place is the formation of tetrachlorocuprate 2 ion. This complex ion is actually responsible for the leafy green color that appeared after this chemical reaction. So, what is the color of product resulted after chemical reaction, and which complex ion is responsible? After observing this chemical reaction, we can easily report the answers. You will add about 10 ml distilled water to the yellow solution obtained in the last step. That yellow solution was due to the complex ion tetrachlorocuprate 2 ion. What happens? See the video. When distilled water was added to this yellow solution, it turned to a sky blue solution. You can understand the chemical reaction with the help of chemical equation. Complex ions of copper are producing different color in this chemical reaction. The yellow solution turned to the sky blue solution is due to the formation of tetra aqua complex of copper. Tetrachlorocuprate 2 ion has changed to tetra aqua complex of copper. This is actually a ligand exchange or substitution reaction. It is a type of chemical reaction in which ligand in a compound is replaced by another. So that's why the olive green or the leafy green colored solution turned to sky blue color. Now slowly add concentrated aqueous ammonia to the solution to the test tube containing hydrated copper ion solution, and you will add until the precipitate appears. These precipitates appeared in the form of bluish-white precipitate. What are these bluish-white precipitates of? You can understand with the help of chemical equation. When concentrated aqueous ammonia was slowly added to the test tube containing hydrated copper ion solution, what happens? It forms the bluish-white precipitates of copper hydroxide. These copper hydroxides are appeared as copper dihydroxo dihydrate, but more conveniently it is written as copper hydroxide, because another way to write this complex is copper hydroxide dot 2H2O. So when these two water of hydrogens are removed, then this product will be simply written as copper hydroxide. Ammonia, after removing two water molecules from this sky blue colored complex, form ammonium ion, as you can see in the product, and the hydroxide ions are combined with copper and forming copper hydroxide, bluish white precipitate. Continue adding concentrated aqueous ammonia to the test tube. What happens? The bluish white precipitate will dissolve. In the previous video you saw the appearance of bluish white precipitate in this test tube when excess of ammonia was added, so the bluish white precipitate that appeared in excess, those bluish white precipitate will be dissolved. What product is forming that is responsible for this royal blue coloration, or responsible for the dissolution of bluish white precipitate, you will see in the next slide. With the help of chemical equation you can understand it easily. When ammonia was added to the test tube in excess, the bluish white precipitate dissolved and forming the tetraamine copper 2 ion complex, that is giving the royal blue color to solution. And this royal blue colored complex is square planar in structure, as you can see the structure of this complex as well. Now, after observing the video and after just having a look upon the chemical equations, you can answer the question, what is the color of the solution and which ion is responsible for this color? What is the meaning of these arrows in this picture below? Actually, the arrows are indicating the nature of reaction, is it endothermic or exothermic. So the direction of arrows are indicating it is an exothermic reaction, and as well as it is a ligand exchange reaction as well. The ligand exchange reaction in excess of ammonia and exothermic reaction. So this is all overall the explanation of chemical reaction. Now add dilute nitric acid solution dropwise to the solution that is obtained in last step until the color change occurs. The royal blue color will diminish and you will see the sky blue color appeared in the test tube. To understand this, let's recall the Lewis acid and Lewis base concept. What happens? The lone pair on the nitrogen atom of ammonia shares its lone pair of electron with H plus of nitric acid, forming the dative or coordinate covalent bond, making ammonia a Lewis base, and while the proton of nitric acid are acting as Lewis acid. So let's consider the equation ammonia reacting with proton and forming ammonium ion. Now, as you can see, ammonium ion has no pair of electron to share, so it can no more act as a ligand. Actually, the complex ion destroys by the addition of nitric acid. So in this way, there is no more tetraamine copper 2 ion complex, so therefore no royal blue color will retains and forming the sky blue colored aqua complex of copper. So the royal blue color of the solution changed to sky blue color. Now in next step, you will transfer about 2 ml of copper nitrate solution to a test tube, and then you will add about 2 ml of ammonium nitrate solution. So you will see, is there any evidence of formation of the dark blue or royal blue complex ion? So what do you think? What will you observe? Let's have a look at the chemical reaction first in the video. Have a look at the equation. Copper nitrate reacting with ammonium nitrate, so forming ammonium nitrate and copper nitrate. That means reactant product side both are same, so you are having no color change. That means there will be no tetramine copper 2 ion complex formation, so no royal blue color will appear. Now you will add 2 ml of sodium hydroxide solution, as you can see in the video, to the test tube, and now see what happens. The ammonium nitrate reacting with sodium hydroxide and forming tetramine copper 2 ion complex. That's why there is royal blue color in the test tube in excess. Again, you can see the more clear vision of royal blue colored complex. Addition of sodium hydroxide to the test tube containing copper nitrate and ammonium nitrate will lead to the following chemical reaction. That means ammonia is going to be formed. Now copper amine complex formation will take place here, and that is already present in the test tube in the form of copper nitrate. So ammonia will react with this copper and forming the royal blue colored complex. So what is the role of sodium hydroxide here? You will report sodium hydroxide first reacts with ammonium nitrate, and as a result ammonia will form, which can behave as a ligand. Hope you have got all the points of complex ions of copper. Thank you.